All right, so continuing, finding the right size wire. So I have a lot of notes here. I don't know, should I write them for you?
Depends on what it looks like.
I don't know, so it depends on what they say. It's a lot of writing from me. 22, 23, probably. All right, use that. Or 3 intermittent. Note that these charts keep from exceeding, or keep you from exceeding, or keep from exceeding the maximum voltage drop. The max voltage drop. So we talked about the maximum voltage drop for each type of voltage system, whether it be 28, 14, or the higher ones. These charts are already set up to make sure that you don't do that. So it's not like you have to do this and then that. This works for that. So let me see, voltage drop, assuming a few things. One, wire is in free air. Wire is in free air, not in a bundle or conduit, so not in a bundle or conduit.
What's conduit?
Conduit is, we don't have an example in here, it's metal tubing where wire runs through it. Oh, right there next to you.
Oh.
There you go, conduit. And wire is in an environment of 20 degrees C or less. And that is 68 degrees F. So 68 degrees F or less. So if I'm going to run a piece of wire from the cockpit out to the wing, I live here in California, is that something that I have to worry about, this 68 degree F?
Yep.
Well, to a certain extent, maybe. But as soon as even if it's a 100-degree day, first thing I do is I climb up until my outside air temperature is below 68. That's where I like to run. I like to run it at 68 degrees or less. So and you're going to lose 2 degrees Celsius per 1,000 feet. So it's not that hard to get up to 68 degrees. So, not so much. I'm not going to concern it too much. But I would take in consideration that yes, it is going to be hot. That wire is going to be close to 100 and some degrees inside of the wing when I'm down on the down below. But what if I'm running it forward to the landing lights, which happen to run right next? The wires run through the forward of the firewall, around the outside of the cowling, and then to the front, right next to the engine exhaust.
It'll be pretty hot.
It's always going to be hot there, so I'm really going to consider that. So, yeah, of course I'm going to consider the 68 degrees and really think it through. What is the temperature of that wire, and make adjustments. But when I'm going forward to the firewall through the engine, there's no kind of saying, well, it's usually about 68 degrees. There's no getting around that because it's never going to be 68 degrees unless it's parked in the middle of winter. All right.
Number one there, let's say wire is in free air?
Free air.
Oh.
Free air.
F-R-E-E. Well, it actually says it right here. So I just copied what I wrote. And then I already said that. You must know, what do you need to know before you can use a chart? Right, you must know voltage, wire run in feet, and amps. All right, so we went through the example, which I don't have to write any of that. Number 1, which you guys did great. Let's try example number 2. Let's see. Example number 2. And let me see. Oh, we already did example 2. Figured out the maximum length of a wire. We did good. Let's see. Well, it's kind of the same thing. So what was the maximum length of wire? Current slide, slideshow, current slide. So let me think, what do we got here? What is the maximum length of number 8 wire? Number 8 wire that can be used for a 28 volt system at 50 amps. And I think we already did that, right? And then we came up with 50 amps. Come down here, I have 28 volts. I have number 8 wire. Number 8 wires here. So we go right there. We came over here. We had 30 feet. Okay. Now that's assuming what again? What are my assumptions? Free air and not.
Not in a bundle?
Not in 100 over 68
Oh.
degrees.
Okay, right there. Voltage drop chart. Continuous flow at 20 degrees Celsius, and it does have the part number for that wire. Let me see. I think it's somewhere here. Free air somewhere. Okay, but what if, using that same thing, what if the max temp is 50 degrees? So now how are we going to figure that out? Well, right down here on the bottom, it gives a little formula. But if you're watching online, you can't see it all because my little face is covering it. So I'm going to write it over here. I'm going to take this, come over here, and discard that, over here. And this is the formula. And it's not something you're going to memorize. It's right there on the chart. So it is L2 equals 254.5 times L1 divided by 234.5 plus T2, where L1, L sub 1 is wire length calculated. L2 equals new wire length. And T2 is wire temp. So if we plug that all in, we want to find the new wire length right there. So,
Where is C2?
huh?
L2.
L1, L2. You want me to-
Why is it T2 and not T1?
Oh, I'm glad you asked that. Who else cares? I don't know. Don't care. Sorry. I got a long list of things I care about. That was just not on the list. Well, they had a meeting. Okay, so L2 equals 254.5, because that's a constant and that's given, times what?
L1.
L1, what do we calculate L1 at?
30.
30 divided by 234.5 plus T2, which is
50 degrees.
50 in Celsius. So we just work that out. I didn't even bring in my calculator, so you're going to have to help me out. L2 equals, what's my top number?
7635.
7635 divided by, so it's 254.5 times 30 is 7635. 234.5 plus 50 equals 284.5. We're going to divide those two things, and L2 equals so 7635 divided by 284.5 is
26.83.
26.8
Or 84 here.
feet. So my wire get longer or shorter?
Shorter.
Why did it get shorter?
Because of the heat.
Well, so yeah, why? Why do I have to make it shorter? Because when it gets hot, it's going to grow to 30 feet? No. Because why?
Resistance?
What about resistance?
So there's less resistance because the shorter feet, length of wire?
Why do I need less resistance?
More current?
Well, how about
Maintain current?
how about when the wire gets hot, it's going to have more resistance,
Yes.
and so it has to be shorter now. So cooler wire would be better. Joss?
Does the temperature have to be in Celsius?
Yes. Absolutely.
I need to move standard.
I could put that
Temperature,
in C. What?
Everything else we measure is going to be in standard, but yet temperature we measure in Celsius.
That is a fact. In aviation, that is, I mean, you call up ATIS, you listen to anything, and they're going to give it to you right in Celsius. I freaking hate it. I got to always transpose
What's
it.
the conversion again for Celsius? Isn't it times 0.3 something?
Celsius times 1.8 plus 32 equals Fahrenheit. That is not something I'm going to do in my head too well. So you can kind of double it in that 32, but all right.
Hey, Kevin,
Yeah?
why do we, for the chart, we're trying to keep the wires from not using too much voltage drop.
You
Yet
wanna
we rate
keep-
the fuses in amperage. Why is that?
wait, what?
No, it's a good question. So as far as the wire goes, we seem to be overly concerned about voltage drop, but yet fuses are rated in amperage. Okay, so it's kind of a double thing you have to think about. So number one, whenever you talk about wire, you could almost just think, if it wasn't aviation like cars and stuff, you just think, well, this wire has to be rated for that amount of amps. And I guess to an extent, I don't know if anybody works on homes, it's kind of the way homes are. It's like X number of amps equals this size wire. And you don't really hear anybody talk about voltage drops and stuff. And so you can actually kind of get away with that and just say this wire is for this amperage. Except when we get into aviation and we're a little more persnickety, we have long runs. You know, cars, you just don't have a very long run. I mean, you know, unless you have even if you had a motor home, a pretty big motor home, it's still not a long run. But, you know, think about how big, you know, even a small Cessna is. From wingtip to wingtip, it's a long way, right? What's that, 36 feet? Yeah. So,
Actually 36.4.
depends on which wingtips you have. So, you get into Boeings, Airbuses, and the length is really long. In fact, the length of those aircraft are so long that when you actually do cable tensions, and you have to be concerned with the fact that when they're cold, they're one size. When they heat up, they're a different size. So they actually grow in the heat. They're so big. So this is just kind of my thought on this. So once you start getting these longer runs, especially with direct current, you have to be more concerned about a voltage drop. And so that comes into play. Now we could actually just go back and just ignore this whole voltage drop thing. I could never mention it, not even worry about it. Just follow the chart. You've got X number of amps. You got X number of feet. What size wire? Boom, that's the size wire. And then it's like, well, why is it that size of wire? Well, two things. One, it's the current carrying capacity, and two, it ensures you don't have a voltage drop that's too much. Hopefully that makes sense.
I wonder how long it took them to come up with the chart.
Probably 2.5 hours.
I don't know how long it took to draw it. God damn.
All right. I'm going to go with number 10. Why? Because circuit breaker. Circuit breaker selection. Okay, according to 4313 1B paragraph 11-51, the purpose of a circuit breaker. The purpose of a circuit breaker or fuse is to protect the wire. Protect the wire, not the component. Which is not to say that they just ignore the component. It's all factored into there, but the correct answer is it protects the wire. Electrical wires. Electrical wires must be protected. Must be protected with a fuse or circuit breaker. I'm going to just abbreviate CB. And what am I going to do with all the time that I saved by just writing CB?
SeaWorld.
SeaWorld. See? As close to the bus bar or power source as possible. So in other words, I can't take a wire run and start at the battery and run it all the way out to the wingtip and then put a fuse out there, a circuit breaker. Well, that's stupid for two reasons. And we always try and do what? Whatever an idiot would do, we don't do that. So that's what an idiot would do. So we won't do that. Why? Because anywhere along that line, from the battery or the power source all the way out to where you ran this wire, that wire's got to go through a lot of aluminum bulkheads and cutouts that are razor sharp. And that wire works its way through that, and now it shorts out, and now it's got a direct short, and there's no fuse protection, so the battery voltage and amperage comes running through there, and that wire gets hot and melty and smokes and starts on fire, and you can't do anything about it because you're hooked up to a battery that's got some 100 and some odd, well, it's got what, 35 amp hours, so it's going to go for 35 amps for an hour, even if you shut down. Well, I guess you shut down the master switch and kill all the power to it, but depends if it's on the. There are a few things in an airplane that are hot. Yeah, maybe.
Wires near fuel tanks are. That's what you were saying. If it runs down the wing without a fuse.
Oh yeah.
Fuel tanks right there in the wing.
Oh, yeah.
You're suddenly going a lot faster than you used to, and you look back, it's because you're shooting flames out.
TWA or something?
Activate the afterburner.
What's that?
Didn't it happen at TWA? They had a 4.7 that the center fuel tank blew up
Yeah.
because of a direct short.
Yeah. So table 4313, table 11.3 can be used as a guide. We'll say for circuit breaker and fuses. And let's see, table 11-3, 11.6, 9, 11.3, there we go. So there's 11-3. So this can be used as a guide. So if I'm using a number 20 wire, then my circuit breaker can be 7.5 with the fuse at 5. So again, wire bundles in 135 degrees ambient altitudes up to 30,000 feet. In wire bundles, wire specifications. So, yes.
Sorry. After saying this, I had a question, kind of backtrack, I guess, as far as the temperature.
Okay.
Right, so I know it says wires and environment. So if we're doing this, I know we're here in California, right? But your plane travels, so wouldn't you take that into account when you're working with something like this wire? Not where you're at, but
No. Okay, I should probably. It's a wonderful question. The last thing I would want to do is build an airplane and say, well, I live in, I don't know what's colder than us. I live in Alaska, so this is how I'm going to wire my plane. God help you if you ever decide to fly to California, because this plane won't work. They're just going to, crash in a ball of fire. You can't think that way. You have to think of the overall environment of the aircraft.
okay.
And so if it's an interior space, you're going to think about what temperature that's going to be running. More than anything, I really think that it has more to do with how it's routed in the aircraft.
Okay.
If it's running near things that are hot, such as the engine or a heater or heater duct, it's running around older radios that heat up. you know, with all the tubes and stuff in it. So that's really more of the thought right there.
It's not necessarily about ambient temperature.
No, I'm going to say no, because I wouldn't do that, because I don't, you know, then what? So there's a joke in aviation once you get used to it, and that's if something doesn't work, you're supposed to placard it, and there's more to it. It depends on the complexity of the aircraft. You have a minimum equipment list, and then it tells you if this thing aircraft can be flown without this, then you have to placard it. So it's just this placarding joke. It's like, so, you know, just placard the aircraft, no flying below a certain, you know, latitude, longitude, or something, you know.
I think every job.
Yeah. So this airplane can no longer.
Nowhere from
Yeah.
California and Florida.
I used an 18 gauge wire, so please do not operate this aircraft anywhere near, you know, above 80 degrees outside air temperature, because that's all I had. So, all right, you should be able to understand this chart right here, so which is not hard. Like I said, if I said, hey, I've got a 10 gauge wire, and what size? I was looking for mine. There it is. So you can see it. Whoa, I have a 10 gauge wire. What size circuit breaker should I be using for that?
40.
All right. And I guess you could use this chart as a cheat sheet and go, I can't remember if a 22 is a small wire or a big wire. Well, if that takes a 5 amp breaker and a number 2 wire takes a 125 amp wire, which wire is bigger?
2.
I hope you'd say 2. Okay.
Deuces.
All right. A, B, C, D, circuit breakers. Are not to be used as switches, are not to be used as switches. And what I forgot to do is Harry actually sent me some old 337s, and I don't have my email on this computer. And they were really cool because they had drawings on the back. And one of them was a sheet metal repair. And it was drawn by hand by somebody back at, I forget the date. It was an old one, 60-something, 50-something?
60s, yeah.
Yeah, drawn by hand. It was gorgeous. You could see I used the compass to make the circles and, you know, just a straight. It's all drawn by hand, you know, and then little X's for where all the rivets went. And then he sent me another one that had a cigar lighter. And note, it's not a cigarette lighter. It is a cigar lighter in aviation. I don't know why, but yeah, you don't call them cigarette lighters. They are, yep, they're listed as cigar lighters. Yeah. And
Because pilots are plastic.
and this particular one had, was that your plane?
Yeah.
Yeah. So they added a cigar lighter, and it just had a simple little drawing of it, had a wire and a fuse and the cigar lighter. Just, I mean, that's all it was. It's like, how cool, but they still drew it and it looked nice. So, all right, circuit breakers are not to be used as switches. I would say there's an exception that isn't written here, and that is the circuit breaker switches that I talked about. That looks just like a switch with a number on the end. That is a circuit breaker switch. That's different. So, but if you have the push-pull type circuit breaker, that's not your switch. You can't, you know, well, how are you going to turn off your nav lights? Oh, I just pop the breaker. Okay.
That's one way to do it.
It is one way to do it, but it's not the right way to do it.
Is it bad for the breaker?
So would you add on to this statement, like circuit breakers not to use the switches except for circuit breaker switches?
Yeah.
Look for numbers at the end of your.
Yeah, yeah.
Is it bad for the switch or for the circuit breaker? I mean,
It must be because they don't want you doing it. And I do think that once you pop them, I know some circuit breakers, yes, the more they're tripped, the more that you use them, the worse it is for them. There are others I heard if you don't actually trip them every now and then, that's bad. So, but yeah,
So the 750s, the Garmin 750s,
yeah,
to go into configuration mode, you have to pull the circuit breaker so that you can press
uh-huh.
the button.
Yeah,
So you put, I mean, we do that a lot.
yeah.
So, I mean, eventually, obviously that circuit breaker is gonna get out. But, like, we kind of use it as a switch. I
You
mean, not-
kind
not
of-
during flight.
Right, and that's the big difference. It's okay to use them, absolutely, because when you read the maintenance manual for a lot of procedures,
Yeah.
the first thing you do is you get in and say, for this procedure, pop this breaker, this one, and this one, and this one. Right? And so it's really normal for us as mechanics to pull breakers. That's why you can pull them. All right? But as a pilot, you're not supposed to use them as the switch. Like a landing light switch, or this is my gear switch. Well, the gear motor runs all the time. I just pop the breaker in, the gear goes down. So don't do that. E, if an aircraft uses fuses, if aircraft uses fuses, and you happen to blow one, there's a little placard on the aircraft, and you're supposed to put your name right. No. FAR 91.205. FAR 91, that's general operating and flight rules. So that really, it's more of a pilot thing, but it applies to us. But you can think with pilots, Part 91 requires the pilot, told you the pilot stuff, to carry one spare set of fuses, or 3 spares of each kind.
So the fuses are in a place that during flight, a pilot can switch it out?
Yeah, the glove box.
Oh.
Yeah, most planes have little fuse holders. You see fuses in there. Yeah.
Right next to the steering wheel.
You throw them in there, and most of the fuses you can reach from the pilot side. They're like my plane, they're right by my knees. Well, if I have circuit breakers now, but my other plane, they were right down there by my knee. So it was not difficult. I didn't want to do it in flight. There are some in an aircraft that you can't get to that are underneath the instrument panel. So you're not fixing those. Like the cigar lighter and a map light.
How bad would it be for a fuse to go out during flight and for you not to replace it?
How bad would it be? What do you mean?
It would depend on the fuse,
Depends on
right?
what it is.
I didn't understand the question, but
How dangerous would it be if a fuse were to go out during flight and you didn't replace it?
well, if it's a communication one and you're flying IFR, life or death. Well, and if it's instrument panel lights in the middle of the day, don't care. So it depends on what it is. If it's, well, you wouldn't put a fuse for landing gear motor, but and starter circuits do not use circuit breaker or fuses. So if somebody said all circuits in an aircraft must have a circuit breaker or fuse, that statement would be false, because we can think of one that doesn't, and that is the starter circuit. So why don't they put them on the starter circuits? Well, it draws a lot of stinking current. Okay, so put a current limiter. And it's a motor, so it's going to draw several times its rated current. But, really, let's think about it. What, we can't get a 200 amp circuit breaker in there somewhere? Sure we could. I think that that's part of the reason. I don't have the exact answer, but my other thought is that, number one, it's a very short duty, and it better be a short duty. I said duty. Item. You're not supposed to just get on the starter and just, you'll hear people doing it though, and it starts melting the wire, it starts melting, the starter gets hot, the solder melts, you blow up, you ruin the starter. So don't do that. When you guys are in 310, 312, 313, and you get to run your engine that you overhaul, I actually use my watch, and I give you, what do I give you guys? A total of 30 seconds of starter use. Period. It's like, and that's over multiple times. So you can do it, but you get 30 seconds. If it doesn't start, once, you have 15 seconds to start it, troubleshoot 15 seconds. Yeah.
So I think you were saying about, you can use an amp limiter. If you use that, wouldn't that prevent it from starting in the first place because it uses so much, like you said, to start?
Use a what?
The
Amp?
limiter?
Current
So
limiter.
from
Current,
limiter,
yeah.
sorry.
Fusible link is what I was actually meaning. fusible link.
Okay.
Not a current limiter, fusible link.
Okay.
But no, the reason why I think there isn't something in there is because it's somewhat of a critical item. If for some reason my engine stops and in flight and I had to restart it, which it should be windmilling, but I think I want my starter to be usable, even if it's causing some major problems somewhere else. I want that starter to be usable. I was actually listening to a podcast where some guy was flying and he lost a piece of his propeller. And so when that happens, even the smallest piece, it'll shake the airplane so violently. You do risk the engine coming out of the aircraft, and then that upsets the weight and balance, and then it backs up all the way to the earth. And since you don't have rear view mirrors in an airplane, it's dangerous. So he, and I never thought about it, but he says, man, I got to get this stopped. So what he goes into it turns off the engine, pulls, it turns off mags, pulls a mixture back, and he goes into a stall so that there's no wind on the propeller, and then levels out and just kind of goes slow enough that it doesn't windmill the propeller. And I'm like, dang. I was thinking it through.
That's quick thinking.
Yeah, that it.
Okay.
That's terrible.
Switches. Snitches get switches, I think.
Ooh, you gotta go pick your own.
Switches, pick your own.
Back to those days.
Must be capable of carrying the load, carrying the load of the wire. Right? Makes no sense for us to go all through all of this work, figure out that we're using, I don't know, a number 20 wire, and we've got a 5 amp fuse, and it can be this long, and then we take a little tiny switch and put it in there, and every time we turn it on, it's like, can hardly turn it off because the switch is so hot when you go to turn it off. It's like, oven mitts, we placard it. Please use oven mitts. Right? So switch is getting hot because you're putting too much current through it. You can't do that. So you got to make sure that you match the switch to the load. Switches are rated to both voltage and current. The nominal rating of the switch is printed on the switch. Printed on the switch. So just look for it. This nominal rating that they give, see, this is the max. This is the max current, or maximum current. Maximum current that the switch can continuously handle with the contacts closed. This is the max current. The switch can continuously handle with the contacts closed. Now you'll find that switches tend to be rated pretty stinking high in volts and pretty dang low in amps. Like it wouldn't surprise me, to say 120 volt, 5 amp. All right, because the volts doesn't seem to be a big deal. It's the amps that really seem to have a hard time with switches. So that's why we end up using relays. Like, because a starter's got aught, double aught, I can't think of the cable offhand. It's fat cable, right? That's running through there. And you imagine the switch rating that I would have to have. First of all, imagine the terminal ends I'd have to put on that wire to, it'd actually be, 1/4-inch bolts that I'd have to actually strap it to behind the panel. And then the switch back there, take 2 hands, boom, start. So that's why we use a relay. Okay, this is kind of an important point. Some loads are higher at startup. And so startup, so switches, switches need to be derated. Derated.
What does derated mean? Like just posted lower than it?
Nobody really knows for sure. I'll tell you in just a second. Let me see.
That's unrated.
Need to be derated for these applications. To ensure long switch life, obviously. All right, so derating is when you take something and lower what it really is. Like, for example, people do this with engines. Manufacturers do this with engines. You take a specific engine that's capable of putting out, say, 200 horsepower, but they'll say, nope, for this application, you can only run it to this RPM. Therefore, instead of putting out 200 horsepower, it's only good for 180 horsepower. So you derate it. Say, this engine now is only 180 horsepower. I'm like, well, why? Because you can't have 200 horse in that. We just have,
They don't want you to have fun.
yeah, we just have all of these engines. And, well, we don't want to make a whole new one, but that particular whatever can't handle this horsepower, so we just limit it somehow.
So they lie.
They lie, yeah.
Those lie.
All right, but in this case, they're not lying. What they're saying is that, okay, for example, you guys are doing the project where you run the little motor, and I have you hook up the ammeter. Say, well, how many amps is it? How many amps is that little motor? Like 4 amps. But what does it do when you first start it up? The needle goes all the way to the right, pretty far to the right, and then starts coming back. Okay, because the motor is a dead short until it starts running, pretty much. So whatever's going through those wires momentarily is a lot. And if you actually tried to switch it off at that moment, it's seeing all of that current flowing through, and it's going to arc, and that's not good for it. So for certain applications that has a high inrush of current before it's up and operating, you have to consider that as part of the switch life. You don't go with while it's operating, you go with worst case scenario. Yeah.
The 767s actually have heavily governed engines compared to the DC-10s and MD-10s and DC-11s?
Yeah, I was thinking of something like that. I knew one of the
same
jets did.
engine, it just, the 767 is just heavily governed, and it's on the 37s as well that are really governed so that they are more fuel efficient.
And I think they increase the life of it too.
Yeah.
So what are some things that have high inrush current? Incandescent lights. Those are lights that don't have condensance. It's your typical bulbs. Motors and inductive circuits. An inductive means something with a coil. So what has coils? Well, incandescent lights have coils. Motors have coils. Motors and motors and motors have coils. So anything with love.
Let's say inductive circuits.
I don't know where this becomes a problem, but I thought I'd write it in here. Do not use AC derated switches in DC circuits. And table 11-4, of course, out of AC 4313, shows derating chart. And I'll make this point. We'll take a look at that. Switches. Switches used in an electric motor circuit. Switches used in an electric motor circuit. Electric motor circuit must be derated. Must be derated by a factor of 3. Factor of 3 for a 24 volt motor, and by a factor of 2 for a 12 volt motor. I'll come back to that. Don't freak out.
Whoa.
I know.
So are we gonna take a break tonight or
At what time is break?
8:20?
Yeah, what time is it now?
15
So I have how many minutes?
2.
We have 4 minutes.
You know, 120 seconds.
But now you've used up some of my time, so
Nice, go.
He's gonna use up some
No,
of
but
your
wait.
time.
He gets break a minute later.
so yes. So unfortunately, none of you can quote anything from Mr. Hand about time. Somebody laughed. You get that joke?
Nope.
Okay. Right there in the back, right? Yep. So, okay. 11-4. All right. Derating factor. So nominal system voltage. Remember, nominal means 28 or 24. It's like not 28. Oh, mine's 24. I escaped it. No, nominal. It means about that. So, and it just repeats. So if I have a lamp in a 12 volt system, I'm a derating factor of 5. Inductive solenoid relay, which pretty much all relays are, factor of 2, because a relay has a coil in it. A coil is inductive. It has a high inrush of current. A heater, I think that would be more, but okay. But it's just a big resistor, I guess. And then a motor 2. See, a derating factor of 3, derating factor of 2. I will let you have a break now because I think that Zach probably has to poo. And so,
Probably.
And that will be on the
Could
internet.
you go back to the